Hi everyone, Dr. P here, and in this lecture video we'll take a look at the concept of stoichiometry. Now what is stoichiometry? Well, stoichiometry is basically the molar ratios of products and reactants in a chemical equation. All right, so we get stoichiometry from chemical equations. Sorry about my handwriting today. From chemical equations, EQNS, abbreviate equations. So for example, let's take a look at the following. I'll draw it in a different color here. Let's say we had 4NH3, that's gas, plus 5O2, which is gas, and they react to give us, that's a sloppy arrow, sorry about that, 4NO gas plus 6H2O gas. So stoichiometry is these coefficients. So it's the relative number of moles of reactants and products involved in a chemical equation. Now we can use stoichiometry to get conversion factors. So we can then do calculations. So in this example here, we have the following conversion factors. We have 4NH3 per 5O2, and we have 4NH3 per 4NO. I'll put these in parentheses here. Maybe I'll put a comma in between them. And we have 4NH3 per 6H2O. Plus the reciprocals. That is, these guys flipped over. 5O2 per 4NH3. We also can write things like we have 5O2 per 4NO and 5O2 per 6H2O. And lastly, we have 4NO per 6H2O. Now, what do these all mean? Well, really, what it's saying is for every 4 moles of NH3 that react, we use up 5 moles of O2. And we get that from our balanced chemical equation. These conversion factors also say for every 4 moles of NH3 that we use, we produce 4 moles of NO. Similarly, for every 4 moles of NH3 we use, we produce 6 moles of H2O, etc. So we can use these to do calculations. So let's say we had the following question. So let's say we had 1.23 moles NH3 react with excess O2. How many moles of H2O are produced? Question mark. So let's say question here. So let's look at what the answer is going to be. Let me scoot that guy up just a little. So we want to get moles of H2O. And we know we have 1.23 moles NH3. And we'll use our conversion factor that we get from the equation. 4 moles of NH3 per 6 moles of H2O. And really it's just this guy here, but I wrote it upside down because it's still the same. So 6 moles of H2O per 4 moles of NH3. So I can go ahead and cancel my moles of NH3, grab my 30-plus-year-old calculator here, and 1.23 times 6 divided by 4 gives me 1.85 moles H2O. And these coefficients, our moles, molar amounts in a chemical equation, are exact. Okay, so we're going to have 3 sig figs here. So really, what we're doing is we are converting moles to moles. And we're going to use, as a conversion factor, we'll use our stoichiometry. I'll just abbreviate that stoich, sorry. So the important thing to remember is it's all about the moles. Get out of here. All right, this guy's going to keep coming back. I just feel it. All right, so there are some practice problems here. I would say look at some end of chapter problems for mole to mole conversions, because this is stoichiometry at its simplest. We'll actually start using it for, pretty quickly, start using it for mass to mass conversions. Because really, I mean, how are we going to count 1.23 moles of ammonia? And that's an awful lot of, you know, if a mole is 6.02 times 10 to the 23rd of something, that's an awful lot of molecules to count out. So usually we count by weighing. So let me just line these up here. Let's flip that over. There we go. Sorry, I got a new desk. It's a very nice desk, but I'm trying not to mar it here. Don't want to ruin my new desk. Anyway, so what about masses? Since the easiest way to measure the amount of something is to do masses. All right, so let's say we have the following equation. Or let's just give a sample. So EG. Okay. Let's see here. Let's do, we'll say consider the following reaction. And it has the following balanced chemical equation. So what we have here is calcium phosphate, solid, plus 3 moles of sulfuric acid, react to give 3 moles of calcium sulfate, solid, plus 2 moles of phosphoric acid. Okay, so we'll say here, what mass of calcium sulfate can be produced from the reaction of 1 gram of calcium phosphate. Oops, sorry about that. And excess sulfuric acid. Now there's a reason that I'm mentioning excess sulfuric acid, and we'll see that in the next video when I start talking about limiting reactants. But for now, we'll just focus on converting mass to mass. So here we're going to use molar masses as conversion factors. All right. So, and this is actually problem 15, part of problem 15 on the practice problems. So, let's do, we want grams of CaSO4, and that equals, we've got 1.0 grams Ca3PO42. Now, it's all about the moles. I have a 1 to 3 molar ratio, so I need to get from grams to moles. So let's do that. For every mole of Ca3PO4, we have a certain number of grams Ca3PO42. And then we will go ahead and use our molar ratio here. So we will have 1 mole of Ca3PO4 per 3 moles of CaSO4. And then lastly, we're going to have to convert moles of CaSO4 grams CaSO4. I'm leaving these guys blank because I need to actually calculate their masses, and I don't have a, let me go find a periodic table somewhere. Let's see here. Let's do that, and open that up. So on my computer, I'm just getting a periodic table here. It's in one of the appendices, I think. I think I've got a periodic table here. Appendix F, work backwards D. Appendix A, periodic table. All right, so let me zoom in here. And let's figure out our calcium phosphate. So I have 3 calciums. Each calcium is 40.08 grams. Oops, I didn't want to do that, sorry. 3 times 40.08 equals. And then I have 2 phosphoruses. So I've got my phosphorus here, and there's 2 phosphates. So 2 phosphorus, 8 oxygen. So I have plus 8 times 30.97. Damn it. Sorry about that. Let's try this again. Let's start over here because I am just getting off target. 3 times 40.08 equals plus 2 times 30.97 equals plus 8 times 16.00 equals 310.18 grams. So 310.18 grams. All right, and now my grams of calcium sulfate, I have 40.08 plus, what's sulfur? 32.06, 0.06 equals that, plus 4 times 16 equals 136.14. You guys can check my math. I know I'm kind of doing this a little quickly here. So my grams of calcium phosphate will cancel, my moles of calcium phosphate will cancel, and my moles of calcium sulfate will cancel. So that will give me now 1 divided by 310.18 equals that times 3 equals that times 136.14 equals, so this is the number that I get here, 1.316, so it's 1.3 grams. 1.3 grams CaSO4 solid. So now what we've done here is we've gone from a mass to moles to mass. And we've used a molar mass for each of our mass to mole conversions, or mole to mass conversions, and then our stoichiometry in the middle there. So we use molar mass to go from mass of our reactant to moles of reactant, then use the stoichiometry to get moles of product from moles reactant, and then use molar mass of the product to go from moles of product to mass of product. But remember, at the center of everything, stoichiometry is all about the moles. Yes, this guy. Anyway, it's all about the moles. I'll say that over and over again. All right, so in the next lecture video, I'll talk about limiting reactants. And in further lecture videos, we'll go ahead and look at if we have solutions, that is, stuff dissolved in water. And should be wrapping up in a few lecture videos. All right, well, until next time, stay safe out there. Bye now.